Hello everyone and welcome to Tech Majlis. This is a project that I wanted to start long ago. I'm very happy to be starting my first episode today focused on data engineering. Tech Majlis is all about tech related topics. The idea is that I'd love to be hosting different leaders from the tech industry. Today I have a very special guest, someone that I had the pleasure to work with. He's one of the best data engineering leaders that I had the honor and the pleasure to work with in my previous career. He comes from a very long journey of working in big companies in the States and also here in the region. I'd love to welcome Jayant Sonawane. Welcome to Tech Majlis.
Hello, Elal. It's very exciting and really feel very honored that you have invited me to the first episode of Tech Majlis. It's going to be a very exciting session today, and I'm happy to talk about more on data engineering, its applications, and how it specifically applies on artificial intelligence.
Yep, it's a pleasure to be having you today. Actually, a very interesting coincidence that my first episode, I'm hosting a data engineering leader, and the fact that I came up with the name Tech Majlis from ChatGPT. So I've been looking for a name that combines both technology and something that represents the flavor or the culture of the MENA region. So I've been using ChatGPT and it suggested different names. I really like Tech Majlis. And in my first episode, I'm having someone who's a data engineering expert. So tell me about how do you see data engineering in the age of AI today?
Yes. So, firstly, the thing you mentioned on ChatGPT. So it's so great, right? I mean, it has created that kind of thunder, or it's had outbursted the AI world, and the AI has really come to the power of a common man. It's in the hands of a common man now, and it comes with so relevant name. I mean, Tech Majlis itself, it's so connecting, right, to the people and to the region. So data engineering in this AI, and even for the product like ChatGPT, it's so important. And a product like ChatGPT can give this relevant suggestions because it's trained on high quality data, right? You cannot expect anything from AI to give good results if you are giving them some bad quality data, some substandard data sets, and expect it to perform. It's all because it's the data preparation life cycle that goes on in the background that comes to play, and that affects in what kind of predictions or outputs a particular AI or ML model will produce.
So tell me from a data engineering lens, how do you see the challenges of building an infrastructure for like such large scale and meaningful tools like ChatGPT or similar ones? How do you see it from the lens of a data engineer?
Yes, the first very you can say burning pain point becomes for a data engineer is access to good quality data. The data in its raw form, even for trained model, highly trained model like ChatGPT, the data collection, right, is very important for any data engineer. So that data collection life cycle, data acquisition is the first step towards doing any data engineering work. And with that, the subject matter expertise. A data engineer should also understand what the data represents, because if you don't have that kind of context, then any of the process, it's not going to work. The project is will have follow the path of failure. So once you have that data, you should also have the context, and you should have a sizable amount of data with you, so that you can apply all the processes of cleaning, transformations, which are very crucial for training a good AI model. So from the infrastructure standpoint, for data engineer, it first starts with definitely acquisition and collection part, and the second thing is validating the data sets, and then once that validation is done, providing that high quality data to the data scientists or the downstream stakeholders who are actually working towards deriving the insights from those data, and it can be later on to train AI models or do any business decision making or business intelligence work.
So, Giant, you're someone who comes from a very rich career journey. I want you to tell me about how data engineering contributes to solving real-world problems for businesses. Think of things like churn prediction.
Yeah. So that's very interesting problem that you have mentioned. Churn prediction. It's what in basic definition it is that what is the likelihood of any particular customer to come back. Maybe if it's in case of Amazon to buy any product, if it's kind of trading company, then it maybe if it's going to place the next trade or not. So it becomes very important for any business to take to assess this kind of situation, to have the models trained on the very high quality data, and it helps then the specific businesses to take decisions based on, they might want to do a number of things, the customer segmentation, they might want to segment customers into who are your most loyal customers, who are dormant customers, who are frequent customers, right? And the people who are out to be churned are mostly the dormant ones. Then they might want to launch specific campaigns. If it's in case of Amazon, they might want to give such users specific kind of discounts on products so that they are able to bring back the customers into the mainstream. And then from our example, right, at Kafu itself, right, who's a fuel delivering company, and while I was being there, this thing was very big. I mean, for the customers who we want to retain, right? What are the repeat order rate, and if the customer is not ordered probably in last 2 to 3 months, then it becomes very important to how that we can bring the customer back to the mainstream. To do this kind of activities, to churn prediction models, they play a very huge role, an important role for any business. And not only this, right? So there are other practical examples. So currently I'm working at Tarabut Gateway, and it's a FinTech, and it's kind of bringing revolution into the MENA region for open banking and open finance. And we have a good like data science team, and we get plenty of data, transactional data, and those transactional data are messy, right? We need to do a lot of natural language processing on it. So simple example, like when you see your bank statements, so and you in a particular month, any normal person would do hundreds of transactions, right? It can be at a shopping mall, it can be at a restaurant, or it can be pure transfers. So these are all transactions that are recorded in your statement. And when you look at your statement, you want to make sense of it, you are really not able to, because it's such big strings, right? Probably you might also might be wondering, did I really spend on some XYZ transaction? Is it like fraudulent one? That this typical things come to our mind. So the company is really like exactly solving this kind of problems. So they really want to identify the clear merchant name from the transaction, what was its category, when was it spent. So this kind of things, if you want to do this foundational work, transformational work, you need to have access to that kind of data, and the work of data science like NLP models. There are a lot of ML models who can be trained so that they can extract this merchant categories, merchant names from the transaction itself, and give you a clean description of every transaction. And the usage of it, it's for the end users, right? They don't have to wonder of where did I spend my money, and then it helps them to do personal finance management. They can clearly see where I'm spending the most. So this basic thing is clearly not available today. I mean, even if someone is doing its very early stages, so it's going to be very foundational for the work for the region. And all this thing is possible when you have good data engineering practices, and when you really use ML to do really groundbreaking work and foundational work.
Yeah, you actually mentioned two beautiful examples at Cafu and Trabut Gateway. Now, tell me, what does it take to build such a mature data engineering infrastructure from both like resources and tooling point of view?
Yes. So for any level, it depends on where you are at the level of your businesses. So my experience, right, in the past few years, it has been to early stage to mid-sized companies, so startups. And the main problem that comes through here is the hiring people with right resources. So to set up a very good infrastructure, you need good people in your team, right? And finding that is very difficult. And MENA, for specifically for the MENA region, since it's the number of tech people, they are growing, right? They are growing day by day, but still there is a short of demand and supply, and especially in the data world. So for that, the company should really focus, right, from the beginning, that what kind of decisions they want to make. They have to do that foundational work ready, so they know that which kind of resources they want to bring in, and especially the data engineer is the most common one. And then giving that data engineer a very crystal clear path to what the company wants to do with the data, what kind of decisions they want to make. Then that data engineer can go and assess the data sources, have the basic understanding of the data, talk to different teams, get the subject matter expertise, and then you start building on it. And there are a number of things where you can do for building the data infrastructure. Since the region is really adopting the strategy of cloud first approach, and there are a number of cloud vendors that have come to the region now. Recently in UAE we have AWS, we have Microsoft Azure, even in other parts of the MENA world, in KSA, we have OCI, even Microsoft is there now. So when this cloud adoption is increasing, so it brings a lot of good services with it. They have a lot of managed services for data collection, then data storage, then for data querying, which are, it's kind of serverless, right, following the serverless model. So then if you are at very early stage of your business, then using these cloud platforms heavily and their services, it helps you get your foot in the door and really have a good setup in the beginning and start capitalizing on data.
And let's say today, if I'm starting a business, maybe not all startups or companies would have enough resources to build such a mature stack at the beginning. What would be your advice as a subject matter expert in data engineering if I'm consulting you today that I'm starting a business and I'd like to lay basic foundation for data engineering and data analytics? What would be your advice to me?
Yes. So the first thing is, again, as you being a business leader, you should be very clear what kind of data you are getting and what you want to do with at the end. Right? It can be any decision making, as we mentioned. You might want to build an AI solution for trend prediction, and if you're and depends, right? Or it depends on the business the person is working on and what are the burning problems. So you have to have that kind of very good idea on your top 3 to 4 use cases that you want to drive from your data and what kind of decisions you want to make. So once that path is clear, then definitely the resourcing becomes crucial, because then once you hire a particular resource, you have a very clear plan to give it to him or her who is going to work on it. And then you start with the idea of doing POCs on those use cases. That's the very it is fast too, and plus it helps you to assess the tooling, right? You can do research on multiple tools. There are a lot of tools available for data sourcing, data collection. Then there are, and if you're using cloud, then definitely they have plenty of options. Then data storage is very important. Where are you going to store the data? It has to be scalable. If you're if you're getting huge volumes of data and you want to store terabytes and petabytes of it, then you really need a very scalable storage solution. So that is another aspect where you want to do multiple research on multiple tools and do POCs, and then comes the presentation layer, that how you want to present the data, right? And it has to be in very human readable and easy format that anyone at the management level can make sense from it. So to build that kind of a semantic layer is very important for the business leaders. So to do all these activities. So starting with POCs is very important for early stage business, so, because they don't have a lot of knowledge base on what will work. So as we do product market fit, right? So it's kind of the same thing for the data engineering to assess that what kind of ecosystem will work for you. So that's wherein we could start.
You mentioned a very interesting point on product market fit.
Yeah.
Today, many startups in their seek to reach product market fit, they think of adopting low-code and no-code platforms just to get a product out of the door. And then if it's successful, they might keep using or adopting those no-code and low-code platforms. From the lens of a data engineer, how do you see the challenges working with low-code and no-code platforms?
Yeah, so this kind of platforms, so they are very, they have the basic things definitely inbuilt within them, and it's good for rapid development because they provide in a lot of pre-built templates for data preparation, right? As part of, if we are talking about data engineering, the very first responsibility of any data engineering work is data preparation. So these platforms really help in this area, but problem comes when you reach scale, right? When you reach at a good volume of data, then there are at that point you will start to see some typical issues. And this kind of platforms are provided by all cloud providers. AWS has something called a Proof, or then they have like SageMaker and other good services they have included in their bucket, wherein they promote this kind of tools a lot. And even there are a lot of tools coming up. Recently I was going through Upsolver is one of the thing which is coming up in the States. So these tools help definitely to structure. If you are early stage business, then it helps you to get your foot in the door very faster than it would be then self-hosting everything. It would do that, but as you reach some scale, then definitely is wherein the actual data engineering work will start. Then you will need to start thinking of performance. Then you will have to really think of your data modeling, right? There's a lot of data modeling techniques. Dimensional data modeling is there, and then a lot of architectural patterns are there in data engineering, like data lakes, data lake houses. So this kind of adopting this kind of architectural styles becomes important, and then this kind of platforms, they will help you a bit, but right, data engineering as a whole is very big picture. So it's not only kind of coding or writing some few Python or Scala scripts. So it's much more than that. It goes to how you effectively are going to store the data. If your data is big, how you're going to performance tunes so that the data retrieval is faster. How you're going to model the data. So data privacy, data security, governance, discovery, right? There's so many things. So these tools cannot do everything. It's not like one-stop solution or something. So that's why definitely as an early stage startup business, it helps. But as you become mature, then you get to work on variety of other use cases, and the effect of those starts to diminish. Yeah.
Very interesting. So how I see this from an architectural point of view is at some point of time, those platforms might start hindering your growth. Hence, it becomes a technical debt. Now, how do you see technical debt as a data engineer?
Yes, so in specific to data engineering, so what I have seen is a lot of technical debt occurs towards the presentation layer. Company tries to adopt. If there are several teams within several tribes, then every team is like using different visualization layer. One team might use Superset, other team might use Power BI, some other Tableau, and they are doing repetitive work. They might do what have overlaps, and probably each one of them are going towards same metric. Let's suppose the very important metric for you is the if your e-commerce company, e-commerce segment is what is your most selling product or what is not your most selling product. So this kind of things, and might be duplicacies across your organization in getting to this metric. And the worst part is that maybe different teams might be getting different numbers to play with, right? And this happens because there is no strategy you have adopted for reusability. So that's why, at least for this part, wherein it's very prominent in the industry, to solve this, many people are working, or companies, towards a headless BI strategy. And what headless BI is nothing but having kind of a layer wherein you can push your metrics to, and they can be reusable across your stakeholders. So with that, what will happen is you will reduce the number of tools that you will use. You will have one standard pattern of data loading and how data transformations and how you present the data, and with that, it will help you to reduce tech debt. But as organization become larger, and a lot of personal preferences kick in, that creates this tech debt. But companies really should rethink on how they want to align their stack, and give it a, as I said, I personally focus a lot of doing POCs in the beginning, because it answers a lot of questions instead of just going there and using something, and then at the end we come to know it's not working out. So that is also a tech debt, right? You put your resources, time, money, everything, and you're just moving towards kind of a failed project. To avoid that, do those POCs, and then have a unified strategy, right? Build your single source of kind of truth, which is reusable, right? The concept of using reusable components across the organization, it help you to keep your tech debt at minimal. Yeah.
Yeah. One of um, one of the most interesting challenges that I can think of is when you're addressing, let's say, a legacy architecture, and you have your database architecture changing. And this is actually a challenge that we had the pleasure to work on together.
Yes.
How do you see this from a data engineering lens? If your team is working on changes on the database architecture, which is changing your sources, how do you see this from the data engineering side?
So changing any upstream change, right? So these are all upstream changes you're referring to. So as the business is, as you mentioned in a past work, as the business matures, there's a data drift, right? That nature of data keeps on changing. So you need to understand that. And plus, if you are in a transactional system, simple example is schema evolutions, right? It's a typical problem. And with these schema evolutions, slowly, steadily, your architecture is also changing. And you have a typical setup, probably, that is not capable of handling those schema changes. And then there's all sorts of failures and data drifts occur, which affects finally your data quality and your ability to take decisions and trust on that data. So this architectural changes, so now there are kind of proven or techniques that are coming up wherein the data engineering teams can adopt. So one of these technique, which I have implemented currently at Tarabut Gateway, to solve this particular problem, and to make downstream consumers and stakeholders more independent of what's happening in the upstream, is kind of creating a contract. So in the software world, it can be it's called as service level contracts or API contracts, and in the data world, it's called as data contracts. So it's a contract kind of between an upstream teams, like producers, and the consumers of the data, wherein you agree on certain set of data points that you might receive from the upstream, and how then the consumers will read those data points, transform it, and deliver it to your stakeholders. But what important thing it establishes here is that you become more independent of any kind of upstream architecture changes that might happen, and it helps, or it shields you from those this kind of techniques, and it helps to deliver also high quality data. So it's a very interesting topic. Data contracts using event-driven architectures even can be applied to batch and batch loading, but specifically used with kind of streaming data, because that's where a lot of problems occur with, and you get to have kind of a lot of bad data from upstream, to solve that. It also solves kind of garbage in, garbage out thing. So if you don't apply any kind of constraints, quality checks, right, in a pipeline, right, then your data platform or data lake or lake house will turn into a swamp, which is unusable. So to avoid all this and to also safeguard from the teams from architectural changes, this kind of patterns they're coming up, and it should be, I recommend to highly use it.
Yeah, and that takes me to a very interesting point, which is in a consistently changing world, how do you see the relationship between business requirements and data engineering? So we usually face legacies and technical debt
Yeah.
when we have to quickly adopt business requirements or we have changes in requirements. Uh, I usually see it in represented in the relationship between product managers and engineering leaders. How do you see this as a data engineer working side by side with business?
Yes. So for data engineer, right, to really work with any business stakeholders, so that can be product managers, subject matter experts. So the data engineers really need to upskill, and they need to communicate well, and in terms of business language, not technical language. That becomes very important to really understand the actual requirements from your business stakeholders. So a lot of times I see that there is this gap that happens. Probably they are not on one page. They think that you have all the requirements with you, and you go ahead and implement, and then you come to know, no, this is not what we wanted. And all these things occur because is the uh, time you have spent on understanding the data itself, the process you follow really with the business stakeholders. You really need to sit down with them, understand, ask them questions, right? How you will going to understand any requirements is asking them the follow-up questions, and understanding it in and out. So this kind of approach will help you to get the, at least in a nutshell, what you want to do, and avoid any issues or reiterating on the same thing again and again. Though not everything can be understood in the first shot, things change along the process. There is a lot of it. You need to go through some iterations to achieve to an agreeable kind of solution. But that conversation, those communication skills, and actually speaking that business language becomes important for a data engineer. So that's why it's not only technical skills, but a data engineer should also possess those kind of business skills.
And as someone who did have the chance to work in companies of different size, like big corporates and startups and scale-ups, do you see those qualities of a data engineer are necessary regardless of what type of organization that you're part of?
Yeah.
Or do you see those changing based on the environment around you?
So some things can be reapplied across organization, because when you work for different industries, as I worked for maybe real estate, there is crypto, there's semiconductor. So the nature of data changes, then definitely you need to adopt a different strategy based on what kind of data you're playing with, and what's the end goal, right? Or what are you, the first question that comes to my mind, what I'm doing with this, going to do with this data, what is my business stakeholder asking from me. So that's wherein the conversation leads. So some of these strategies in terms of technical solutions, they might remain the same, but in terms of how you handle the data becomes important, and that changes, and you need to adopt based on where you are working at. Yeah, so that is pretty
And
much
across your career journey, you had the opportunity to work in different regions.
yes.
You had the opportunity to work in the States, and you had the opportunity to see the tech space here in the region. How do you see data engineering as a career is different in the States versus here in the Middle East?
Yes, so again, very interesting question. So I came to Dubai in 2019, and what I have seen from this last 4 years, right, there has been kind of foundational transformation changes in the region with respect to the data engineering work. So earlier, maybe a decade ago or 6 to 7 years back, if you think, there was huge gap, I would say, in terms of what work or what use cases the companies were solving, and kind of that kind of startups that were coming through, right? They were not that much, right? We had very few, handful that you can count on your fingertips. But in this last 4 years, I have seen this shift of UAE towards the tech-based economy, and that has really opened the doors for a lot of companies to come in here and have their headquarters and set up and very business-friendly environment. Just if we talk about DIFC, where I work, right, there are so many hundreds of new startups that are getting registered. Like day by day, there are many startups getting registered on a daily basis and working on very niche concepts, right? It can be BNPL, it can be payment solutions related. Like ours, we are more on open banking, open finance. There's so many different companies coming through solving good amount of foundational transformational use cases. So that gap has certainly reduced a lot, I would say, in the last this 4 to 5 years. And the use cases that we are working on, I think they are at par with what would happen in the states, and even the volumes of data, right? So there are definitely many companies maybe Facebook, Meta, Google, they're sitting on piles of data, but that the huge volume generation too is what changing here with let be UAE, KSA, right? So KSA is also becoming a very prime focus, at least in the fintech world, and they have a lot of untapped data. So once that starts being getting processed and comes to light, it will unleash a lot of unthinkable kind of use cases and opportunities for the companies. So definitely, yeah. So I would say the gap is reduced a lot, and there's a lot more in store, which maybe I can't think of right now. Yeah.
So if you see that there is a very big opportunity
Yeah.
for data engineering as a career, what would be your advice for students who are seeking a career in data engineering here in the region?
Yes. So the very first advice is, oh, your mindset. Your mindset should be something that why you want to become a data engineer, right? So how it is different from software engineering or back end, front end, other types of roles. Whether I've seen that this kind of thing coming through new graduates is they want to get into data world, become a data scientist or data engineer or ML engineer, just because it's cool, it's fancy. If you're going towards that kind of mindset, or it pays well, right? So if you're going towards that, right, as a person who is just going to start your career, you are not going to go to like it's not going to take you a long way. If you really want to run kind of a marathon journey, then you have to be very you have to stick to your basics and foundations, and those are in as any kind of maybe a computer engineer, software engineer, or any tech field. It's your coding or programming skills should be good. You should be able to write good code. Then a lot of focus on data structures, algorithms, then Unix-based systems, distributed systems, database systems. This is very foundational. So this should be very clear, irrespective of whether you want to become a data engineer or not. Plus, then if you are really, it's fascinating you, you are, and then it's really you are working with the data, it likes you and feels that you have it in it to do those wrangling activities, to the transform the bigger data sets, then definitely then taking a step forward, getting some knowledge of data infrastructure, data related tools like Airflow, there is Mage, if you talk about Amazon, there is scalable storage S3, there is Athena, there's Presto, then there's Superset, right, catering to different layers of the data platform. So they're getting some hands-on knowledge of it. Then in today's world, a lot of focus is put on full-stack data engineer. So you shouldn't be only writing pipelines, but what about the data infrastructure part? You should be also be capable of spinning that infrastructure on cloud environments. So things like Terraform, AWS CDK, this kind of tool help you. So having that kind of a basic knowledge around it, and then as data engineering, the ultimate goal somehow it is towards predictive analytics for many companies. So basics of MLs you should be having. But again, right, so it's the step-by-step process. But for the very first step is to have your foundations very clear.
Focus on fundamentals.
Yes.
And what do you see like as the different, let's say, branches of career paths under a data engineering umbrella?
Yes. So right now, yeah, there's many again fancy titles that have come up, but I would say that primary streams is that I see upcoming apart from data engineering is the analytics engineer. So there's again subtle difference for like very large organization. Data engineer is someone who would aggregate the data, prepare that data, and then there is analytics engineer who would focus on little bit of data modeling plus talking to several stakeholders, understand the business requirements, write those transformation jobs catering to those business requirements, work on the presentation layer like visuals, dashboards. Um these are primary two areas. Then others can be data architects and then ML engineers. Yeah.
And how do you see those roles as of today in the region, especially in the startup world? Um, can someone be able to do more than one thing? Like you know the word the 10x engineer.
Yeah.
So today you have people working as we used to have people working as front end, back end. Today we have full stack engineers. Today we even have people working in both front end, back end, and infrastructure.
Yeah.
So due to the recent changes in the economic scene, everyone wants to do more with less.
Yes.
So we came up with this term, the 10x engineer. How do you see this in data engineering?
Yes, so as a early stage business, it's very important for data engineers to wear multiple hats. So it's not only working on probably writing pipelines, then it has to be more on data infrastructure side too. As I said, you should be able to if you decide to have in-house infra, then spinning up those infra, maintaining that, plus what that data is used for, having that subject matter expertise and catering to business requirements. And when you cater to those business requirements, a lot of visual aspect comes into picture, let it be dashboards and all. So having those basics in place where you can quickly be able to get something in place for your business stakeholders, it becomes crucial. So bits of pieces of all like data engineer plus data analyst, kind of data analytics engineer, even data architecture, right? Data architect in itself is other stream, but you need to have some knowledge around it, which is data warehousing, data modeling. Uh, so and overall, so as you mentioned, full stack. So it's kind of full stack data engineer who is focused on maybe someone he has one good expertise, but he can also extend that expertise to other areas if the need arises. So it is the need of the time because at any early stage startup they won't be hiring a big team right away.
Yes.
So that the skills that you be learning. So it cannot be. I mean, it's not that you will have everything prior to you join any organization.
It's like having breadth in different
Yes.
areas, but having depth in some areas and having a broader breadth.
Yeah.
Yeah.
Yeah. So learning on job, but you have to have that passion.
Yes.
Yeah, that's the becomes important.
So, Giant, it was a pleasure having you today. That was very insightful, and it has been a very rich episode, focused on an area that I'm very passionate about myself, and it was a great pleasure to have you as my guest in the first episode of Tech Majlis. Thank you again for coming, for showing up.
Yes, thanks, Hilal. It's really, as I said, a very honor to be here and to be present towards your very first episode of the Tech Majlis. It was really exciting to talk about the different aspects of data engineering and how it applies to AI with things like ChatGPT coming, right? It has just created, I mean, that kind of people can not just imagine. I mean, they have like, okay, how is this just possible, right? How the model
Yes.
can be so accurate in
Yeah, it's
terms
like
of
talking to another human being
yeah.
who's very knowledgeable.
Yep, conversational AI, like it's really become reality.
Yes.
So we can think about the future lies, right? It's going to just expand, and the
Yes.
role of data engineers is just going to expand. So yep.
Yep. Pleasure having you today. Thank you for showing
Yes.
up.
Yeah.